In this problem, we're asked to sketch one cycle of the transformed cosine function. So I know that I'm going to need some key features of this graph before I can start my sketch, and so I'm going to find the amplitude, I'm going to find the period, I'm going to find the horizontal translation. This may also be called the phase displacement. And then I'm going to look for the vertical translation, which will basically give us our sinusoidal axis. Right away, the easiest thing to identify without having to do a whole lot of math is going to be our amplitude, and that's this 4 right here. From here, the period is going to be affected by this 1/2, and so remember that anything on the inside is going to be the opposite of what you would think. And so the period, we're going to have to take the reciprocal of that. So the dilation is by 2, so it's going to get 2 times bigger. And so I'm going to take 360 degrees, which if you reference the parent functions of sine and cosine, you can see that one full cycle takes 360. So I'm going to take that 360 times the reciprocal of 1/2, so I'll end up doubling it. So that means that my new period is twice the amount, so 720 degrees. My horizontal translation is going to be found by looking at the inside, and so we're subtracting 180 degrees from theta, so that means that we're shifting it to the right 180 degrees. And then the last feature that we need to identify is the vertical translation, and so that's going to be from this +2, which means that we're shifting the entire thing up 2 units. When you have this many different transformations that are happening to one graph, it's easiest to first graph an intermediate step by just looking at the 2 size dilations. And so the first thing is I can see that my period is 720 degrees. And so what I'm going to do is chop this 720 into 4 equal regions. And so 360 would be the halfway mark, 180 is going to be 1/4 of the way done with the cycle, 540 would be 3/4 of the way done with this cycle. And what I'm going to do here is I'm going to mimic the cosine function, but now going up higher, since my amplitude is 4, and out further. And so looking at the regular cosine, I can see that it will start on the y-axis at its maximum. 1/4 of the way through, it will cross at 90 degrees or hit the sinusoidal axis. Halfway through, it'll be down at its minimum. 3/4 of the way through, it'll be back at that center axis. And then after its full cycle is completed, it's back to where it started. So, starting at the y-axis, I know it's going to reach its highest point, which in this case is now going to be 4. And so I'm going to plot 4 right here. 1/4 of a way through, I know it's at the center axis. Halfway through its cycle, it's down at its minimum, so down to -4. Back to the sinusoidal axis, and then after 720, it's going to be at that maximum point again. And so now I'm going to connect it. And so this just gives us an intermediate step of how the size of this cosine function is going to change. From here, I'm going to apply the horizontal translation and the vertical translation. So I'm going to take these 1, 2, 3, 4, 5 key points and translate each of those. So I'm going to move right 180 and up 2. So right 180 degrees up 2 units. Right 180 up 2. Right 180 up 2. Right 180 up 2. Right 180 up 2. So now that I have these 5 key points, I can just connect them with a smooth curve to get my resulting transformed cosine function. So again, we're at our maximum. Here would be that center axis where it would hit. Here's our minimum, back to that center axis, and our full cycle is done.